Today on circuitvalley.com we are going to attempt repair on this 53131A HP universal counter unit. You can see in the background I already have this big brother of this 53132A from Agilent. I also have other counters, and this counter happened to be, if you look at closely, BNC connectors on this particular unit are damaged, and we are going to replace those BNC unit. I don't think there is any other fault on this unit other than BNC connector himself. So let's go ahead, take this unit apart, and we will try to repair and resolder the two new BNC connectors. I have already ordered 2 pieces from AMP. You can see they are exactly same model. First of all, we need to take 2 screws apart. One is right here, one is right there. Let's do it. This is done. This is also done. Now this will come out as easy as that. And these screws are almost captive because of the rubber, so they will held back automatically. Now you need to take one more screw apart. On the bottom side of the unit there is a screw, same size. Let's take this out. And now this unit will slide like this, like a matchbox, and you have the enclosure in your hand. You can take it aside, and if you look closely, this is the unit we have just taken apart. It does not have any options. We will also be installing one 3 GHz option. And let's see. If you want to see the damage, this is the where it is damaged. Right here. It has fallen on its face. That's how it got damaged. We need to take these 2 screws also apart to be able to take this front bezel. And let's first remove this rubber. The rubber is off. This is there. Let's take this apart. There's a screw here, right here. These 2 screws are not, they don't have any screws, these 2 places, but we can take this apart. One is done. Another one. These are not captive, so they will fall off. You can carefully let them fall off. There they are. Now if you see, the enclosure is held, and you will not be able to remove the enclosure unless you press this a little bit, because it is held by these 2 studs which are blocking it from getting removed. First we need to remove this. Let's remove these 2 nuts. I have already loosened them, so we can quickly remove them. Okay, all of the nuts are out. You need to remove this cable, because this is the cable which connects to the front panel. This is the way it is. Press it a bit, it will release the thing, and you can just push it forward. So if you look at it, this is the connector, and here where the BNC sits. There is no RF signals on this particular board, or no high speed signal on this board. This is just front panel and digital. We can just put it aside. Now let's look at the BNC connectors. These are the damaged one, and these are the replacement. They are exactly ditto same, because I ordered them from the exact same catalog of the parts. This unit has its service manual and every other detail of the service available openly on the internet, so you can get whole part list, and we just have to desolder these, and we will then resolder our replacement connectors, and we'll be done with it. It may not be perfect, but I do not have habit of desoldering on live on video. I may decide to play one trick, is that if you see, this connector is held by 4 pins. 2 are for mechanical rigidness and rest of the 2 pins are the signal. And you can in theory access those signals from the back. So if I cut these pins right here, I would have 2 less pins to desolder, or at least I would have to not take this much effort because I do not have a desoldering gun. So let's do it. I have cut one. I've got another 2. Let's look at properly. One more is there, is cut. So now we only have to desolder 2 of the pins and then connector should come out. I'm using this specially thick desoldering tip for my JPC. We need to add a little bit of solder so that it flows better. And it also have some flux on it. Let's do it then. Need to heat up quite a bit of mass before it can desolder. You can see how quickly it becomes solid again because there's a lot of mass behind this. Not too high at temperature, because if you're too high at temperature you may damage your board. I can heat both sides at the same time. The connector should come out. It came out easily. Same thing we can do with the other one as well. It is basically ready to fall by itself. That's it. We clean up the board, remove the solder. Let's remove the other 2 pins as well. I will need a pinset. Tweezer will be needed. Let me look for the tweezer. I found one tweezer. I will hold them from the back and remove them one by one. Pins are removed. Now you can probably see what was the damage which was caused by falling. Maybe it's a little bit too short distance to focus, but the connector's front is damaged. There is no other damage there. I have got my solder pick from Chemtronics, and let's try to use this. I'll add a little bit of flux. This flux is rosin based flux, really good quality. I have packed it in my own bottle. I bought it from Mother, and it's really nice quality bottle. I have been using Chinese flux bottles all the time and they keep getting damaged, so I decided to buy a nice one this time, and made in USA from Menda. And let's apply a little bit of flux so that wick can flow easily. With this big hose, one trick you can do, you can fold your wick like that, double. And now let's try one more time. Okay, so one of the hole is clear. Second hole is also clear. Same thing we need to repeat for the other unit. These small holes are very hard to clear with this big tip, so I'll change to the small tip. That's also clear. We need to add a little bit of solder. Let's add a little bit of flux. And this is the ground wire, very hard to suck the solder out of it. Let's try the other hole. Yeah, very easy, almost in one shot. All 4 holes of both of the connectors have been clear. Let's clean it a bit, and then we will put connectors. I have put some alcohol. Let me get my paper towel back and clean it. So this is the connector. Let's try to put both of them in before we solder them. Let's try to put both of them in before we solder them. One of them is fit. Let's go with another one. Another one is also fit. Let's fold them back a bit and put some flux. While holding the connectors, I'll put some flux. Go back to my bigger tip. Let it come to the temperature. Now, first solder the studs, only one of them, so that it can hold. Okay, now it will hold. Now we can solder the pins. Solder the next stud. On this side, we'll do exactly the same thing. Solder one of the pin, solder the stud. It's a little bit too much solder, but that will melt. I'll remove it a bit. That's it. Let's solder the pin silver. I cannot quickly reach it. And now clean this thing a bit and then we should be ready to go. Got some flux. Let's put it back together. Put the front panel first. Okay, let's see if it seats properly. Now it should be properly seated. Both of the sides. It's done. So before I put screws, I will let it run first and see if this works. Power is connected. You can see here the fan. Now turn it on. Unit turns on. Self-test pass. Let's connect a signal to it. I'll generate a 10 megahertz. I'll generate a signal from my Siglent signal generator. Let's carefully plug it in because there is no support there on the PCB. This is 10 megahertz sine wave, 1 volt peak to peak. Yeah, good enough. Connector works. Let's try on second channel. Frequency 2. Exactly the same thing. So we have a successful repair. Now that it's tested, we will install a 3 GHz module into this and we will see how a 3 GHz module works. So instrument is again sitting on my bench. We will be installing a module like this. This is a self-made thing which I designed, and I also have source code and everything else published on the internet. You can visit www.circuitvalley.com for more information. This is an open source module, 3 GHz option for 53132A and 53131A. This unit happened to be 53131A, and we will install this module in this and see how well it performs. Module get installed on these 4 holes, connects to this particular small connector which is on the corner, and BNC connector get installed right here in the front. I will remove this cap and we will install the BNC connector first, and then we will screw in the module. Before we install 3 GHz module, let me put the screws back together, which holds the whole thing so that we do not damage it. One screw done. Another screw. Also done. Let's install the BNC nuts as well. I will install them loose a bit because I want to adjust the enclosure still. Maybe it needs a little bit of adjustment. Let's install the BNC connector now. If you can see properly, this hole is keyed. If you can see, this hole is keyed and this BNC is also keyed. I'm supposed to install it like this. Put our little washer there. Connector have been installed, and let's install the module now. Module goes like this. Module goes in like this. Let's put in some screws so that they can hold it. I don't know if it will fit. It doesn't fit. So it's screwed perfectly. Now I will connect. Now I'll connect the connector. This BNC goes right in here to give it a little bit flex. This MCX connector connects like this. MCX should be connected like this, and flex cable goes right in here and it should click. So you have a 3 GHz option installed. Let's connect back the power and we will see if it works. So power is connected. Turn it on. And let's see if channel 3 options appear. There is a channel 3. So for this test we will use my RF generator and we will feed in 2.4 GHz. Let's see if it works. RF level is set to minus 40 dBm and you see 302 MHz. Let's switch to 2.4 GHz. 2.4 GHz and you have 3.9981 GHz. I have just turned on my RF signal generator, so it's OCS, so it's not currently completely warmed up, so it may be having different result. This repair is done. We can close the instrument and it will work perfectly. You can visit www.circuitvalley.com.